The example I'm going to give is my own system. I have an off-grid cottage outside of Gong Hills, and it's 500 watts. It's a big system, but by solar home system standards, but it should give you a pretty good idea of the steps you go through. So the first one is step one is estimate the load, and you need to know the amp hours. Step two is to estimate the size of the array. How many modules do you need? And for this method, we need to know the charging current, and that's in amps that the solar panels are going to be delivering. Step three is you want to know the battery capacity, and the battery's capacity is in amp hours. So your battery is your water tank for electricity, and so you want to know how big that battery is going to be, how many do you need. And system voltage is part of that, because sometimes you use 12 volts, sometimes you use 24 volts. Some systems will use 48 volts. So you need to know what your system voltage is. Step four is to look at the controller and the inverter and say how big are they going to be, and how are they going to fit with the array and the load. And then the final step is to size the cables and the other BOS, that's balance of systems that are going to go into the installation. So it's actually, if you've got a house or a cottage that's far away, you got to do all these things and then pack all this stuff up and take it to the site. And it's all got to be there, and it's all got to be ready to go and work together. So it's a pretty complicated process for a 50-watt solar system or a 100-watt solar system. So let's have a look at how I estimated the load for my cottage that I use on the weekends and play music in. Well, I sat down and I listed all of my appliances that I use, and you can see that you've got the DC appliances and AC appliances. The AC is supposed to be blue, but it's not, so it's down. There's DC at the top and then AC halfway down. So you have to divide your DC appliances that are going to run from 12 volts and your AC appliances that are going to run through the inverter. And then you need to know the voltage. You need to know the power of the appliance. You need to estimate how many hours you're going to use it for, and that's important because you don't want to overestimate it. You don't want to underestimate it. And then if you multiply that, you get the watt hours a day. So look at the refrigerator at the top. It's a 60-watt Focus refrigerator, Sundancer. And it runs for about 5 hours a day, so that refrigerator is using 300 watt hours a day. And if you look at the donut on the left, you can see that 17% of the electricity. So you run through that. I've got my small LED lamps. I've got a security light. I've got a large LED lamp. And I've switched all of my lights over to LEDs because those are a little bit more expensive. I'm finding LEDs, they last a lot longer, and they use a lot less electricity. I have a halogen spotlight because I like the quality of light. It's easy to work with. And then through the inverter, I'm running a laptop computer. I'm running phone chargers. I'm running an amplifier for a band that I practice with once a week. I have a small music system, MP3 player, and then I've got an AC lamp in the bedroom. So you can see all together, you've got all of your appliances. You add it all up. I didn't do it here because I'm moving pretty quickly. You've got your losses, and see that arrow is pointing up. That's 508 watt hours a day. So the losses is the biggest category. Now you take all of that and well, what I've done is I've divided it by 12, and you can get this out of my book. But the daily requirement that we need to power my system is 186 amp hours a day. That means that the solar modules have to be producing 186 amp hours a day after losses. So I need 186 amp hours going into my batteries a day. So the next thing is, how do I figure out how many modules I need? Well, what you need on the left, you can see that there's the average kilowatt hours per meter squared per day. Now, this is the energy that's coming from the sun per day in the various months. And the way a solar designer does is he takes the lowest month. So in Nairobi, our lowest month is July. And in July, you get 4.2 kilowatt hours per meter squared per day. In the intensive months, you get 6.8. You can see in February. Now, so throughout the equatorial regions, you get between 4 and 6 or 6.5 kilowatt hours per meter squared a day. In the U.S., you can get 4, 5, 6 in some places, but in the Northeast, it'll be down 2 or 3 in the winter. So you multiply the design solar insolation value, and that's 4.2, by you divide by the daily amp hour requirement. So our daily requirement was 186 amp hours a day. We divide that by the insolation value, and we get 44.3 amps. And what does that mean? Well, at the voltage, which is 12 volts on this system, you need 44 amps coming from your solar array. So what I need is a group of modules that produces 44.3 amps when it's sunny. Now, what I'm using is about 500 watts of solar, and that's a little bit more than 44 amps, but it's oversized. So that's how you figure out the array size. So you want to know how many amps in the sunny part of the day your array is going to be producing. You can use modules are rated in watts, but actually what you want to know, I mean, a 50-watt module will tell you it's 50 watts, but that doesn't tell you how many amps it's producing on a sunny day. You need to find that information, and that's in the data sheet. Moving quite a